Hello everyone, welcome back to my channel. In this video we will learn about binary complement representation. Okay, so we'll learn about binary complement representation. Okay, if you are first time to my channel, please consider subscribing and hit the bell icon to get video notifications from my channel. Right, so what I mean by binary complement representation, so that is we are confined with binary number system only. For this video we are confined with binary number system only, but actually every number system will have the complement representation. Every number system will have the complement representation. Okay, we'll see that. Okay, so what is complement representation first? So generally addition is the simplest arithmetic operation. Yes or no? So we can perform addition easily when compared to subtraction. So addition is the simplest arithmetic operation, right? So complement representation enables us to find subtraction or difference or subtraction between two numbers using addition operation. Right, so by using addition operation we can find the subtraction between the two numbers. So that is the main usage of complement representation. That is, if we have two numbers like a and b, so we have to perform a minus b. So this can be written as a plus of minus b, and this minus b is called complement of b. This minus b is called as complement of b. So first of all we'll find the complement of b, that is minus b we are going to find, and then we will add it to a. That is, the subtraction operation is performed by addition operation here, because addition is the easiest arithmetic operation. Okay, so that is called as complement representation. And one more important point here you have to remember is complement representation is used to represent negative numbers only. Okay, so complement representation is used to represent the negative numbers only. Okay, so I hope you have understood why complement representation is used and how we are going to use. Right, so next point here is every radix. Okay, suppose I am taking it as R. Every radix R consists of two types of complements. Every radix. Okay, so not only binary number system, hexadecimal number system, octal number system, decimal number system, every number system consists of two types of complements. First is called as radix complement, or it is called R's complement. Okay, R's complement. And second one is called diminished radix complement. Or it is called R minus 1's complement. Okay, so suppose if you take a binary number system, radix is 2, right? R is equal to 2, so it will have 2's complement, yes or no? R's complement means 2's complement, and r minus 1's complement, that is 1's complement. Right, we have 1's complement and 2's complement. This is for binary number system. Right, so for decimal number system, what is the r value? R value is 10, radix value is 10, so it will have 10's complement and 9's complement. 10's complement and 9's complement. Very simple, right? So similarly, octal number system will have 8's complement and 7's complement. Similarly, hexadecimal number system will have 15's complement and 16's complement. 15's complement and 16's complement. Okay, so we'll see all the number system complement method in my successive videos. Okay, so in this video we'll learn about this binary complement representation. Okay, so let me take one more slide and explain you about binary complement representation method. Okay, so next we'll see binary complement representation. Okay, so how to represent the negative numbers in binary number system. So there are three methods. Okay, three methods to represent complement representation in binary numbers, that is to represent the negative numbers in binary. To represent the negative numbers in binary, we have three methods. So first is same 1's complement method. We have seen this, right? Every radix will have r's complement, r minus 1's complement. So we have again 2's complement method, and the third method is called sign magnitude method. Sign magnitude method. Okay, so these are the three methods we have: 1's complement, 2's complement, and sign magnitude method. Right, so 1's complement of number is obtained by changing all zeros you have in the number to ones and all ones to zeros. Okay, so 1's complement of a number is obtained by changing all zeros to ones and all ones to zeros. Okay, so we'll see an example, then you'll understand very clearly. So 2's complement is obtained from, so 2's complement is equal to 1's complement plus 1. So this one is added to LSB. This one is added to LSB. That's all. So this is 2's complement method. And sign magnitude method. So sign magnitude method in this, so the positive numbers in sign magnitude method, the positive numbers will have the MSB value is equal to 0. If MSB value is equal to 0, then it represents a positive number, and if MSB is equal to 1, it represents a negative number. So if MSB is equal to 1, it represents negative numbers, and remaining digits, so remaining digits means other than MSB represents magnitude of the number, Okay, so remaining digits represents the magnitude of number. Okay, so if you want to convert an positive number into negative number, so you just have to make the MSB bit as 1. Okay, So we'll take an example. Suppose if you have minus 65. Minus 65 is the number in decimal, and you want to find its corresponding ones complement, twos complement, and sign magnitude method representation. So how can you find this? First of all, this 65 has to be converted into binary, because all these ones complement, twos complement, and sign magnitude method are applicable only for binary numbers. So first of all, we'll take positive number plus 65 and we'll find its corresponding binary. So successive division method, 2 3s are, 2 2s are, so remainder is 1, 2 16s are, remainder is 0, 2 8s are, remainder is 0, 2 4s are, remainder is 0, 2 2s are, remainder is 0, 2 1s are, remainder is 0. So you have to take this in this order. So plus 65 can be represented as 0 1 0 0 0 0 0 1. Okay, so I'll write again. So plus 65 can be written as 0 1 0 0 0 0 0 1. Okay, this is plus 65. So if you want to write minus 65, okay, so I have taken in reverse order and kept in MSB as 0, because we have to convert this into sign magnitude as well. So if you want to find minus 65 in ones complement method, so what you have to do is you have to find the decimal equivalent, or sorry, binary equivalent of plus 65. That is what we have found here in the first step. Okay, so if you want ones complement, what is ones complement? Change all zeros to ones and all ones to zeros. So if you want minus 65, change all zeros to ones. So 0 is here, so you convert it into 1. So 1 is there here, so you have to write 0. Next 1 1 1 1 1. This is 0. That's all. This is your ones complement representation. Ones complement representation. So if you want to find minus 65, complement of minus 65, you just have to find first plus 65 representation in binary and convert each digit, each zeros into ones and ones into zeros. You'll get the ones complement. And what is twos complement? Twos complement is just adding 1 to it. So if you want to twos complement of minus 65, so what can we write? 1 0 1 1 1 1 1. This is also 1. So to this LSB, this is called as LSB bit, right? Least significant bit, right? Most bit is called as least significant bit. So if you add 1 to it, so 1 0 5 1 0. If you add 1 to 8, so it will become 1 0 6 1s. Okay, so this is called as twos complement. Next, if you want to find minus 65 using SMM method, that is sign magnitude method. So here MSB is 0. Here MSB is 0. That is why it represents a positive number. And if MSB is equal to 1, so if you change this 0 value, if you change it to 1, then it becomes a negative number. So all the remaining bits represents magnitude. This magnitude is 65. So if you change the MSB bit, if the given MSB bit is 0, so it is a positive number. If you want to convert it into negative, that is if you want to find for minus 65 using sign magnitude method, if you want to represent it, so just change the MSB to from 0 to 1. So it will be 1 0 0 0 0 0 1. So this is magnitude which is unchanged, only change is with respect to MSB bit. So MSB is now changed to 1. So when MSB is 1, it represents a negative, and this magnitude represents 65. So it will be minus 65 in sign magnitude method. Okay, so this is how we can find the ones complement, twos complement, and sign magnitude method representation of a given decimal number. So first of all, that decimal number has to be taken as positive and convert that into corresponding binary, and from that you can represent ones complement, twos complement, and SMM method. Okay, so the important here is, let me take one more slide. Okay, so let me take one more slide. I'll explain the range of representations of these complement representations. Okay, so next is a range of complement representations. Complement representations. So this is very important concept and will be asked many times in competitive exams. Okay, so you have to remember the range of this complement representation. So for n bit number, for an n bit number, so for 1's complement and SMM, for both these, the range of representation or range of the representation in complement is, in 1's complement or SMM, is minus 2 power n minus 1 minus 1 to plus 2 power n minus 1 minus 1. Okay, similarly for 2's complement representation, the range for n bit is minus 2 power n minus 1 to plus 2 power n minus 1 minus 1. Okay, so this is the range of representation of the complement numbers, that is both 1's complement and 2's complement numbers. Okay, suppose for if you take for 6 bit, right, so if you take for 6 bit, when 1's complement and 2's complement, this range is representation of decimal numbers. This range is representation of decimal numbers, right? So for 1's complement and 2's complement, using 6 bit, you can represent the decimal numbers. You can represent, so this is representing the decimal numbers. So you can represent the decimal numbers from minus 31 to plus 31. That's all. And for 2's complement, sorry, 1's complement, sorry, this is not 2's complement, this is 1's complement and SMM method. And similarly for 2's complement method, you can represent it with from minus, so this will be minus 32 to plus 31. Okay, so this is the representation of decimal numbers for 6 bit. Okay, so for 6 bit binary number, you can represent the decimal numbers from minus 31 to plus 31 using 1's complement, and for 2's complement you can represent from minus 32 to plus 31. Okay, so this is the representation and this is the range of complement representations. Okay, so we learn here binary addition and binary addition. Okay, so binary addition we will learn here. So what is 0 plus 0? 0 plus 0 is 0. 0 plus 1, we know that it is 1. 1 plus 0 is also 1. And what is 1 plus 1? 1 plus 1 is actually 2. Right, 1 plus 1 is actually 2. This 2 can be written as 1 0 base 2. Right, so 1 0 base 2. This 0 is the resultant and this 1 is the carry. So 1 plus 1 is 0 with carry 1. Okay, so because we require this for learning further concepts in 1's complement and 2's complement method, so I have discussed here. Okay, just remember this, and very important, these complement representations are very important. Okay,